Hey guys, welcome back to my Vulcan 4x hunger run, and in this episode we're going to take a look at setting up a fully automated furnace. Now when we talk about a fully automated furnace, we are of course talking about using an IC program. Now what's interesting about this particular automatic furnace setup is it's actually one of the cheapest automatic furnace setups you can possibly set up. And the reason it's so cost effective to set up is thanks largely to Vulcan and its hydrogen rich atmosphere. On any other planet, setting up an automatic furnace would require you to at the very least capture hydrogen into a tank with some kind of gas smelting and capture system before you could even think of setting up an automatic furnace. So quite a bit of work and quite a bit of steps. Of course, on Vulcan, the hydrogen-rich atmosphere combined with our starter oxygen tank gives us literally everything we need to set up an automatic furnace. Conversely, however, on every other single planet, it's much easier to get started smelting. You just pop down a furnace, go mine some oxides and volatiles and stick it inside. On the other hand, that not so simple basic manual furnace setup that we built a couple of episodes ago is actually very similar to what we need for our fully automated Vulcan furnace setup. There are only some minor adjustments that are needed to make it work as such. So we're just going to extend a chute out around the side of this furnace over here so that we have an area where we can basically just drop a bunch of ores in and our automated furnace will just start to smelt all of them. Now when we say automatic furnace, what we actually mean is that we're going to smelt one target alloy at a time. So if you popped in several stacks of copper, then it would proceed to smelt those several stacks of copper for you. If you popped in one stack of coal and 3 stacks of iron, it would proceed to make 200 steel for you. However, you would not be able to mix two different things together, so you can't pop in coal, iron and copper and expect the furnace to know what to do with that. But regardless, it means we can make a large amount of a single alloy at any given time, dropping in the multiple stacks needed and just letting the furnace go ahead and do its thing. Which on Vulcan is especially valuable early game compared to other planets, as there's a much higher ore density on Vulcan and you're able to build larger and faster because of the increased mining capacity, and hence you have an increased smelting capacity, or I should say a smelting requirement. Now I still don't have another computer built, so I'm going to once more just borrow this computer for my IC programming. As mentioned before, we use a power controller to actually isolate an area of the power cable network, or more importantly the data network. So only devices on that set of cables will be able to see each other and talk to each other. So when you're running through your your IC housing screws trying to assign the different devices to the different diodes, it's much easier to find what you're looking for because there's much few total devices that housing can see. Okay, the sun is busy setting, so the temperature should be cool enough to open up these wall panels without doing any serious damage. Now we're installing a pressure regulator on the oxygen line leading up to the gas mixer. This will allow us to control the amount of oxygen in the pipe between the regulator and the gas mixer, effectively allowing us to actually throttle the throughput of the gas mixer, since the gas mixer won't mix gas unless it can obtain both its inputs gases in their respective ratios. So this cabling is just there to carve out some space for the IC housing to reside. For the script to control the furnace correctly, we need to separate the input and output lines that we're both using the same open vent. So we're going to still have the input line using an open vent, which we'll place over there. And then we're going to add an active vent for the output line so that the script can drain the furnace much faster than would normally be possible with just natural pressure flow through an open vent. Now let's load up the furnace script that I prepared ahead of time. It's mostly been tested with a creative sandbox on the moon, so there may still be some minor tweaks needed for Vulcan. I think I've prepared those tweaks mostly ahead of time, but we'll have to see in the live example how it goes. There's an error. Why is there an error? Of course, telling me the screws aren't set yet. Of course there'd be an error. First screw is the furnace, but I can't seem to find it. Oh, of course the furnace isn't wired up. The furnace itself has a data port which needs to be wired up for the housing to be able to talk to the furnace. Okay, that noise is pretty annoying. Something sounds like one of the pressure regulator or the gas mixer or something is trying to turn off or on to the same state the whole time. That's weird that they would allow that, though. You should be able to set the same thing to the same state the whole time from a script and not have to hear a sound like that, because it's obviously a very useful thing. It saves on a number of lines of code if you don't have to check the state of something before setting it to the same state. So I don't know what's going on there. Hopefully in the final revision of the script before I publish this video I can get that sorted out. So we're going to go try and mine ourselves as many ores as possible for our new furnace setup while the night is still young. Okay, so we had a pretty decent mining run over there, so let's get to smelting some of this stuff. So we're going to dive straight in the deep end and go for the big bad boy first, smelting Invar, which is 1 part nickel to 1 part iron, and has a very difficult 6 to 7 megapascals of release temperature pressure required, along with 1200 to 2000 degrees Kelvin. So it's quite a nasty target to hit and very far off from all of the other ores, which is why this furnace script actually treats it separately from all the other ores, which it picks one target range that matches all the other ores, and Invar on its own with its own settings. Okay, so far so good. Or not. It looks like my previous plan to pump all the gases out of the furnace from the pre-smelting phase while we're dealing with the Invar isn't going to work out, because as soon as the new gases start going in there for the final release target hit, it's kind of auto-igniting because the hydrogen coming in from the atmosphere is hot enough to cause that when it mixes with the oxygen. So that means two things. One, that pumping all the gases out of that furnace from the pre-smelt phase is pointless, waste of time. So I'm going to set it to the same 4 kPa as the other ores are all set to. We can just start igniting and pumping more gases in immediately for the release phase. And two, with those combustion settings, the amount of oxygen and hydrogen I marked as being required for initial ignition, it's probably not going to get anywhere near the Invar target. Okay, I can see that the build up is also too slow. That gas isn't getting in there fast enough for the Invar. It's kind of cooling down too quickly. So let's do something here. I had a flat 100 kPa for both Invar and non-Invar. Let's do a switch instead. So for Invar it will be 400, and for non-Invar the regular 100. Also, this switch over here is no longer needed since they're both now running on 40 kPa, and I gave up on venting everything out for Invar's sake to have a more controlled ignition process, which clearly isn't going to be possible on Vulcan with the pre-igniting gases. We're still not hitting our target pressures for Invar though. That's strange. It's already set to the minimum pressure for the Invar. It will build up the ignited gases until that point automatically. Oh, I'm a tart. It did reach the target pressures, it made the invar. So let's put that back to the 6000 it was on, because it actually was fine. Okay, let's try a non-invar ore this time. Another blend, we'll do Constantin, which is 1 part copper to 1 part nickel. So the script actually goes through 2 phases. The first phase, it puts just a little bit of gas slowly but surely into the furnace in a controlled manner to keep the temperature up just enough to actually melt the contents of the furnace, which, like I said before, is much less than the actual temperatures and pressures required to release the stuff. The only problem is that I see that it's not quite building up enough temperature fast enough to be able to keep melting the ore, so I'm just going to increase that throughput there a bit for this first phase. Once it's melted all the ores, it then tries to pump out those gases till it gets to about 40 kPa, and then it starts building up fresh oxygen and hydrogen fuel mixture and ignites it, and then keeps building that up until it reaches the desired pressures and temperatures for releasing pretty much all non-invar ores. And there you can see it just released the ore once it hit its target mark. And there you have it, a fully automated furnace. You can literally drop your ores in there and walk away. So let's do some steel next, which is, we're going to do 3 stacks of iron and 1 stack of coal, because steel is 1 coal for 3 iron. I'm still a bit nervous about the adjustments to the script, so I'm just going to watch it for now, but it looks like it's melting at a very nice speed. Melting all the stacks of iron and coal. For those of you that are wondering about scripting a furnace, the slot number 0 is actually the input of the stack of ore that's busy being smelted, basically the top input of the furnace, that's where it's kept. And for the items that actually have been smelted, they're actually listed separately from the slots data and are actually a category of the furnace called reagents. So they're actually direct variables on the furnace itself called reagents, and variables related to that, like reagent quantity, etc. Then slot number 2 is actually the output of the furnace, which will only ever briefly, well, slot number 1, sorry, is the output of the furnace, which will only ever briefly flash as you open the release valve and it passes through the output slot. So next, let's just smelt the remainder of our iron. So I'm fairly confident that the setup is working now, so I'm going to go ahead and replace that computer I stole, because I keep stealing it, so I clearly need to build another one. But I can't see it, so it's probably a research tech. So let's build a research module, red there, and go check. Start processing those research modules along, and for our next ore, let's just smelt the remaining copper. So computers are actually available from the sorting systems research tech. Do not ask me why. Nah, I just built a bunch of computers. Forgot to check on it. that was wasteful. I suppose I can always just sell the rest or something. There's the communications board I stashed earlier. I'll just stick that inside the computer. And I'll also just pick these up before I forget about them. And in goes the silicone. I love that that furnace is just fire and forget. So we're going to stop it there for now. Links to the IC program used for the automatic furnace will be included in the video description. I'll include a link to the Steam Workshop item for it, as well as a link to stationeering.com for the IC simulator for checking out the program. Although I obviously tweaked this program to make it work better on Vulcan, the exact same script will definitely still work on all of the other planets as well, provided you're supplying your own hydrogen and oxygen mixture, of course. That's all I have for today, but in the next video we're definitely going to be doing some aggressive base expansion. So until then.